Morning, everyone. Since I work for a commercial company called U-Series, based in Italy, in Bologna, today I would like to talk about stable isotopes from the point of view of a private laboratory. U-Series is mostly focused to consultancy and services in the radioactivity field. Our experts assess radioactivity risk, detect radiation in the workplaces, and support companies dealing with transport, trade, recycling, and reuse of material containing radioactive isotopes. The company also organizes training sessions for workers and to protect themselves from radiation risks. We also have a very well-equipped laboratory for preparation and analysis of samples that can be sent directly from the customers, but we can also provide service for sampling if required. Our most important activity is the analysis of radon in air, but in our laboratory we can analyze alpha, beta, and gamma emitters as well, and clearly stable isotopes. We can handle many type of materials such as metal junks, construction materials, waste, environmental samples, food and beverages, and also biological samples. We are regularly requested to analyze water samples for total radioactivity emissions, radon, tritium, and also stable isotopes. And most commonly, we analyze tap and bottled water, or also water used in the industry for cooling machinery and water coming from landfills. We are equipped with an old-fashioned maybe, but still reliable Delta 5 Advantage. So it's an isotopic mass spectrometer coupled with a high temperature elemental analyzer. So we analyze water in its liquid form, but we can also analyze the solid samples. The most commonly requested analyses from our customers are in particular water collected from inspection wells around landfills and water for human consumption. Other samples that we analyze for stable isotopes, but not directly related to water, are food and beverages for detection of fraud and verification of the geographical origin. Fertilizers also we analyze, and carbonates and nitrates dissolved in water. Going back to the schematics that Josie showed you earlier, our most important reason for using stable isotopes is to determine pathways of possible pollution. And pollution in a general definition, so not necessarily pollution from radioactive losses, but also pollution from unexpected water sources in the case, for example, of the bottled water. So in this activity, we have to face some critical steps that may deeply affect the results and the quality of the results. So those steps during the whole process that we have to take particular care of. In particular, sampling is one of the most relevant steps that we have to take into consideration. In fact, the analysis of water-stable isotopes require particular attention to sample handling because water can easily evaporate and this can deeply affect its stable isotope signature and therefore the results. Usually, a commercial company can also provide support in sampling, but if it's the customer doing the sampling by itself, which actually happens most of the times, it is very important that the service supplier provides the customer with all the necessary information for doing the sampling in a proper way. Already at this stage, it should be therefore necessary to have a reciprocal understanding of needs and the requirements both of customers and service provider in order to ensure the achievement of the expected results. Another critical step is within the laboratory, including sample handling when the samples are received, sample analysis, and the delivery of the results. To ensure high quality standards, it's getting more and more common for, especially for private laboratories, but also public laboratories, as far as I know, to be accredited from independent organizations who can verify that the laboratory works properly. that all the quality controls are in place, and therefore that the results are reliable and reproducible. The most common accreditation labels are ISO 9001, which is a general accreditation on quality management, and ISO 17025, which is specific for organizations that perform testing and sampling. And finally, there is the interpretation of the results. And here again, it is very important to have exchange of information between the customer and the service provider. So as Jesse pointed out earlier, stable isotopes are very useful tool to guide and to provide information to water managers, as Manuel and Matthias showed us with their case studies. Stable isotopes and isotope analysis is getting popular not only among universities and research centers, but also to the number of private laboratories providing these kind of services is increasing every day. Private services are maybe most expensive than going to public institutions, but the service is more customer oriented and is driven by the customer needs. And in fact, private companies are open to collaboration with customers to develop new methods to answer specific needs, but also to collaborate with universities and research centers to develop applications inspired by research activities. And thank you for all your attention.